Walk outside on a clear day and look up, and you see a massive dome of blue. For most of us, this is a static, unquestioned backdrop to our lives. The sky is simply blue. But the source of that light, the sun, does not emit a blue glow. The radiation hitting the top of our atmosphere is pure white light, and the environment surrounding our planet is a total vacuum. It is entirely, overwhelmingly black. Curious, if a white light source is shining through a pitch-black void, where is that glowing blue dome coming from? We live at the bottom of a massive, invisible ocean. This is a layer of transparent gases, mostly nitrogen and oxygen, which intercepts the sunlight long before it reaches the ground. The blue sky is not an empty space or a solid object. It is an optical illusion created as transparent air molecules actively filter white solar radiation. To see this filter in action, we have to look at the microscopic level, right as a single beam of sunlight enters the atmosphere. Sunlight is actually a mixture of every color in the visible spectrum, each corresponding to a specific wavelength. Notice the red light at one end. Its waves are long and stretched out. At the other end, the blue and violet waves are tightly packed and much shorter. A principle called Rayleigh scattering determines how these waves travel through the air. The long red waves are large enough to pass cleanly through the gaps between gas molecules, but the short blue waves are different. Because of their size, the blue light physically collides with the air molecules and ricochets outward in random directions. Because this blue light is shattered and bounced across the upper atmosphere, it reaches your eyes from every angle in the sky simultaneously. The sky appears blue because these short wavelengths are mathematically more likely to crash into air molecules than to pass through them. This leads to a logical problem. If shorter waves scatter more often, and violet is shorter than blue, why isn't the sky purple? The first reason involves the upper atmosphere. High-altitude oxygen and the ozone layer are highly efficient at absorbing high-energy wavelengths. This acts as a primary filter, soaking up much of the violet light before it reaches the lower levels where scattering is intense. The second reason is biological. The human eye is simply more sensitive to blue light. Even though some violet light is scattering, our visual system interprets the specific mix of colors reaching us as a clear, pale blue. The sky we see is the result of this multi-layered process, a specific balance between our air's chemistry and the structural limitations of human vision. Because the atmosphere is a physical filter, we can adjust the environment. We can start by turning the dial on distance. At noon, sunlight takes a short, direct path. But at sunset, light travels a longer horizontal path through dense atmosphere. Here, blue and violet waves scatter away early. Only the longest red and orange waves reach your eyes. Now we can adjust the dial for particle size. What happens when moisture in the air gathers into clouds? Individual water droplets are much larger than nitrogen or oxygen molecules. These droplets are too big for Rayleigh scattering. Instead, they bounce all color wavelengths equally. When these colors scatter together and recombine, we see white or gray light. The colors of the sky are indicators of the light's journey. A red sunset shows us how far the light traveled, while a gray cloud shows us the size of the objects the light hit. We can test one final variable, density. Moving from the ground to a high mountain peak or an airplane, the sky takes on a deeper, darker blue. The higher you go, the thinner the atmosphere becomes. With fewer gas particles to scatter light, the sky loses brightness and begins to fade. If we move our observer out of the atmosphere, the environment changes instantly. As the camera emerges into the vacuum of space, the blue disappears. Without an atmospheric filter to shatter the incoming waves, the sky returns to its natural state, pure black, even while the sun is shining. Next time you look up, remember that the blue isn't just a background. You are watching the physical result of starlight